Hello guys, welcome to this channel. Today, let us solve this circuit problem. According to the problem, we are to determine the currents I sub 1 to I sub 4 as displayed here in the circuit drawing. I sub 1 has a direction as well as I sub 2, I sub 3, and I sub 4. And for B, we are also tasked to determine the voltage across this current source, and the current source as displayed here in the circuit diagram is 3 ampere. This is the circuit symbol that we are using. It is attached at points A and B. To be able to solve for the unknowns, we have to set up algebraic equations from this circuit's diagram. And let us consider this point A and use Kirchhoff's current law. According to the Kirchhoff's current law, the current that goes through the point is positive and the current that goes out from that point is negative, and it is equal to 0. So in this case, I sub 1 is positive, I sub 2 is negative, and this part where the current source is attached also to the node A, you see that the arrow is going away from this point, so that will be negative also, and it is equal to 0. So KCL at A, this will be our equation. I sub 1 minus I sub 2 minus I3 equals 0. So this is our equation 1. And for another equation, we can use also Kirchhoff's voltage law. We take the path EACGE. The voltage law states simply that the voltage rise minus the voltage drop is equals to 0. So if we are going to take this path, the part that we encounter here, if it is rising, it will be positive, and it is dropping, it will be negative, considering the voltage on that elements. So we have here the voltage source, which is 12 volts. If we are having a clockwise direction, this will be voltage rise, because this one is negative and this one is positive. So that will be voltage rise, so plus 12. And as the current enters the positive element, the polarity will be positive, and it goes out with the polarity of negative. So the voltage of this positive element, 2 times I sub 1, this is actually voltage drop, so that will be negative I sub 1. So also with this one, this is positive and this is negative, so this is also voltage drop if we are having our clockwise rotation. So that will be negative 3 I sub 2 and equal to 0. So this will be our equation 2. Now we can solve this this equation, by using the technique of simultaneous solution. So we take equation 1 and equation 2. Okay, so we rearrange equation 1, I sub 1 minus I sub 2 minus I3. We place the constant on the right side, so also with the equation 2, and then we place it here. We just rewrite I sub 1 minus I2 equals 3, negative 2 I sub 1 minus 3 I2 equals negative 12, and we will solve this simultaneously. So to be able to have the simultaneous solution, we must have a constant value that is common to the variable in consideration. For instance, I sub 1, I want it to be have a common constant here, which is I will be multiplying this equation to 2. Okay, so when I multiply that one, it will give me 2i sub 1 minus 2i2 equals 2 times 3, that will be 6. And then copy again this equation. So now we can have a cancellation here. So to be able to cancel I sub 1, which has a common constant here 2, since this one is positive and this one is negative, so we just add the two equation. So if you are going to add the two equation, okay, this will be cancelled out, and you will be given here, you will have here a 0, and this one addition of negative 2i2 and negative 3i2 is negative 5i2, and 6 plus negative 12, that will be negative 6. So we can now solve for i2. Okay, so that's it. So negative 5i2 is equals to negative 6. So i2 is 6 over 5 positive. Or by having the decimal value, you have I sub 2 is 1.2 ampere. So this is our I sub 2. To be able for us to solve for I sub 1, we can use either equation 1 or equation 2. Okay, so I will be using equation 1 here. So equation 1 is I1 minus I2 minus 3 equals 0. So I'll substitute I sub 2 here, which is 1.2. And then you know that negative 1.2 minus 3 is negative 4.2. And you place it on the right side. So you have I sub 1 is 4.2 ampere. So this will be our I sub 1. So we already have the value for I1 and I2. How about I3 and I4? Again, let us consider this point B and have the Kirchhoff's current law here. So the current that goes to the point minus the current that goes out from that point is equals to 0. So KCL at B is 3. This is going to that point, positive 3. I3 is going away, and I4 is going through that point, so that is positive. I4 equals to 0. So that will be your equation. And for your Kirchhoff's voltage law, we take the clockwise rotation, BF, HD, B. So voltage drop and voltage rise. So this one again is the equation. Negative 6 volt is voltage drop. Since this is positive and negative, this will be voltage rise. So plus 5 I sub 3. And this one is actually I4 is passing through these 2 ohms. So this is a positive point. This one is positive, this one is negative. Again, I'll mark this positive, negative. Again, so this is negative and this is positive. Okay. So 2 times I sub 4, the voltage, this voltage from in this element is taking the loop BF HDB is actually voltage rise. So that will be positive and it's equal to 0. So the same thing that we are going to do as we have done for solving I sub 2 and I sub 1 by simultaneous solution. So we will have this result. For I3, we will have 1.714 ampere. And for I sub 4, we have negative 1.286 ampere. So we already have the values for I sub 1, I sub 2, I3, and I4. How about the voltage across this current source? So we consider this point A, B. So the voltage at 3 ampere is the voltage AB. We don't know the voltage here, but we can know the voltage by going through this path. So you have A to B. So you consider AE AC, I mean CD and CB. Actually, you can also go from here A, E, G, E, D, H, F, B, but this one is the shortest path, and it is much better for us to take the shortest paths to avoid error. Okay, and to be able to have that, okay, let us solve for the B sub AB. What is B sub AB? B sub AB is actually the voltage of this 3 ohm and this battery, this 4 ohms, this battery, and the voltage of this 5 ohms. So for the 3 ohms, you have 3 times I sub 2. So this is plus and minus. So we have here a shortcut thing. We place it on the right side, so the voltage drop here, okay, which should be negative, becomes positive. So 3I sub 2. This one is voltage rise, 4 volts, but it is placed on the right side, so it will become negative 4 volts. And this one 4. But what is the current of 4 ohms? Let us assume that it is going to this direction. So you can assume also in the other direction, but my assumption is going to the right direction. I will name it as I sub x. So we will get this one. What is the value of that? So we take the Kirchhoff's current law here. So you know that I sub 1 is going away from this node, I sub 2 is entering this node, and negative I sub x is going away from this node. So this is the Kirchhoff's current law. We have already the value for I sub 1 and I sub 2. So we just plainly substitute it. For I sub 1 you have 4.2, but since this is negative I1, so it will be negative 4.2. And I sub 2 is 1.2, so this is plus I sub 2, which is 1.2 minus Ix. So it is simply as for negative 4.2 plus 1.2, which is negative 3. So negative 3 minus Ix, or Ix is equals to negative 3. So this value, this negative 3 amperes, is the Ix value. Okay, so we can now use it here. So since this is going through the passive element, so this will be the positive one, and this will be negative. So this is voltage drop, and place it on the other side, so it will become positive. So 4, and then multiplied it by the current. So current and the resistor is voltage, so that will be 4 times negative 3. And this one, so this is 6 volts voltage drop, negative 6, and place it on the other side, positive. So also this one, 5I3. So this is voltage rise, place it here on the right side, it will become negative, so negative 5I sub 3. So but since we have already the value for I sub 2 and I sub 3, I sub 2 is 1.2, I sub 3 is 1.714, we just plainly substitute it. 3 times I sub 2, which is 1.2, minus 4 plus 4 times negative 3 plus 6 plus 5I3. Okay, and this is the value for I3, 1.714. Therefore, if we calculate this one, the answer will be negative 14.97 volts. So that will be the value of B sub AB. So this is how you solve this circuit problem by using Kirchhoff's current law and Kirchhoff's voltage law. Thank you for watching this video. I hope that I add knowledge to your learning desire. God bless you.